continued tense. I don't know when I'm stuck in Ozark High School and calculus drags on. But Miss Mac keeps talking and it goes on and on. When I was just a freshman, I had Miss Sappington. She said to pay attention. Boy, she wasn't wrong, I didn't heed her warning. Instead I closed my eyes. When that function discontinues, I hang my head and cry.
I don't get it!
Aw, hey Daniel, what's the matter?
I don't understand continuity.
Continuity? Why, continuity's easy. Come on, I'll show you.
Is this continuity?
No?
Dang it! Is that continuity?
No, but that was discontinuity.
Is this continuity?
Look, maybe we should try a different approach. So what we're trying to understand is continuity, right?
Right.
Continuity occurs whenever you have a continuous graph that is smooth along all points, which is what makes it continuous. So for example, you might have a note that plays and is held for who knows how long. That the whole time the note was held, so it was continuous. But then there are two types of discontinuity that we have to worry about. We have to worry about removable discontinuity, which can occur whenever there is a small break in the graph that does not follow the curve, that is, 1 point. So, for example, we might hold out the note and then have the slight break of 1 point and have the note again. Then there's another type called non-removable discontinuity, which occurs whenever there is some sort of jump or point that cannot just be simply placed in to make the graph continuous. So, for example, you may press the note and then suddenly you may jump to a different note, such as the higher note in this case. And that is an example of non-removable discontinuity because there is a jump.
Okay, that makes sense. So, continuous, removable, and then non-removable.
So this is the problem I've been having trouble with.
Oh, well, that doesn't look too bad. I think we can manage this. So we're trying to find the points of discontinuity, right?
Well, it says that.
So points of discontinuity are going to be anywhere that the equations are either undefined or, in the case of this piecewise function, where they merge may be a possible point of discontinuity.
Oh.
So first, why don't we check the first equation for any possible undefined points?
Okay. So that will be 1 over x minus 1.
Right. Now, where can a function be undefined? What conditions will it have?
If the denominator is equal to 0.
Exactly. So how can we make our denominator equal to 0?
Well, since our denominator is x minus 1, if we set that equal to 0, our x will equal 1.
Fantastic.
So we just plug that in. We get our 0. Nice little undefined.
Further proof that our equation has an undefined point at x equals 1. So now why don't we look at the second equation?
Okay.
So we have x cubed minus 2x plus 5.
Yes, we do. Okay. So let's write that out and make it all official.
Alright, so are there any possible undefined points for this equation?
Doesn't look like it.
Alright, so we now have our undefined points. Now where was the one other spot that I said we could have possible discontinuity?
At the union.
Exactly. So our union point is going to be at 1, correct?
Correct.
And we already found out that in our first equation, x equals 1 is the spot of the vertical asymptote. So why don't we just try drawing a quick sketch at the graph in order to see if we have any discontinuity.
Okay.
So if we think about this 1 over x minus 1, and we know that there's a vertical asymptote at x equals 1, then we come up with this. Now, if we think about the original equation of 1 over x, which all calculus students should have memorized, We remember that it's going to look like this, except it would originally be hugging the x-axis instead of 1.
Okay.
Now, what we're looking at and what we're seeing is that this is going to go infinitely downward the closer that you get to 1, meaning that it can never connect with any one sole point in order to be continuous. So we know that it's going to be which kind of discontinuity?
Non-removable.
Correct. Well, I think that was
So
our
thanks for
problem.
helping me with continuity and discontinuity.
Oh, anytime, Daniel. I'm happy to help.
I finally understand it.
Function discontinues when intercept is gone, and sometimes called a jump or piecewise function. I know I had it coming. I know I can't be free. But that function discontinued, and I just tortures me.
Blooper reel.
Go! Get that one, though.
Is that continuity?
Oh, but that was discontinuity.
Is this continuity?
No. How do you feel?
My eyes feel like they're gonna explode.
You should probably not do that.
I can't, I'm stuck.
Oh. That's a problem. Matthew, help him.
Let's see what I have to do all the work.
Oh, you have to do all the work. But gosh, Matthew, don't you know what you're doing? How are you doing? You better? You all good?
Yeah.
Look me in the eyes. Tell me you're okay.
I feel